Hello, I hope you all survived week 1 of class. Today we'll be going over some material from Module 2, where we'll start to analyze some of the data that you gathered in the first week. Just as a little reminder from last week, here's the signal that we had from moving the accelerometer back and forth, where we've got our peaks here that we're measuring from point to point. We then wrote down the times for all of the peaks of our signals. And then we used this formula here to determine the time between our hops. Now, I think I misspoke in the last lecture and called that the frequency. That's actually the period here. The frequency is just, 1 divided by this period, and we'll get into calculating that next. We'll want to make a column called Hertz. When you're going through exercises like this, you want to make sure to label these top rows very explicitly. You might remember what's going on right now without those labels, but if you ever have to come back to these worksheets, you might get really confused and have to step through it really slowly. Here, we quickly know what each column is, so it'll be easier to come back to. Our formula for frequency is the inverse of the period, or the time between hops, and that is just defined as 1 divided by the period. Just like with our period data, you can click the line that's at the bottom of that first cell, and click and drag it down. That should auto-populate the rest of your frequency data. For Module 2, Homework 2, you'll be submitting this frequency right here, which is the frequency of your hops, not the frequency of the pendulum or arm swinging. And we'll want this isolated in its own Excel file. So go ahead and highlight the letter that's at the top of this column. It should highlight everything. Hit Control C, and then we're going to open up a new Excel file and then paste this in there. I've opened up a new Excel window here, hit Control V after I've clicked in this first cell, and you can see it's populated with a bunch of errors. The reason for that is all of these cells, it's trying to reference the formula that we wrote that references specific cell numbers. Since it's not referencing that sheet, it can't find it. In order to fix that, we just need to click on this here. This is our paste options, and we'll be changing this to just read in values rather than the actual equations. In our paste options, we'll want to select this one at the left here, which will just paste in the values that we calculated in those cells, and we'll just disregard any of the formulas that we wrote for them. In our paste options, we'll want to select this one at the left here, which will just paste in the values that we calculated in those cells, and we'll just disregard any of the formulas that we wrote for them. After clicking on the Values Only button, we see that our frequencies are properly populated into our spreadsheet. You want to save this. Make sure you save it as Module 2, Homework 2, and then put your name in here just so I don't get files jumbled together. I'll be compiling all of these, and we'll send out kind of a master spreadsheet that has everybody's frequency of their hopping data, so that we can analyze the entire class together. I'll anonymize these so your names won't be associated with the frequency now, but you'll also be doing this separately with your own personal hopping data. Before we get into calculating the mean, the variance, and the standard deviation in Excel, I'd like everybody to go to Module 2, Instruction 2, and there's a video here that's an intro on statistics that you should go through and watch. If you're looking at this as a PowerPoint presentation, you can just click on the YouTube link here, but you don't necessarily want to have to type that in. It's this same link that's in your instructions. After you've got that homework file submitted, let's go back to your hopping data file and we'll start to analyze and determine both the mean hopping frequency as well as the standard deviation. Right here is our formula for the mean. Our mean is defined as the sum of all of our frequencies here, and then we divide that by n, which is just the number of items that are in our list. We can do this in Excel by using a number of different formulas. So if you want to click here in your total, our formula is sum, always going to be equals, of course. Special equations and functions in Excel are always going to be capitalized. So we're taking the sum. You have to then do this open parenthesis, and then you can select all of these cells, and then of course the close parentheses here. And then that should give us a total frequency that we can then get our mean from. Next, we need to know the total number of data points we're dealing with. We could very easily count these since we know it starts here, it's row 14, and our first one is 2, so we know that there's 13 data points. If you've got a lot of these, or if they're offset, it might be a little bit harder to count. We can use a built-in function in Excel called count. Again, it's going to be all capital letters here, and then just drag and select all of our cells of data. Count will determine the number of these cells that have real numbers in them. So in my case, 13. Finally, I just create a column here called mean, and our equation for the mean is now our total frequency data from column O divided by the number of points. You can see that equation right up here. We end up with a mean frequency of 1.46 hertz. And that does seem to match up with our frequencies that we've measured. It should be right in that same range. Next, we'll be calculating the standard deviation of our data. This gives us a little bit of insight into how reliable or how variable our hopping data is. A very low standard deviation means that our frequency data here should be really consistent from one hop to the next. High standard deviation means that there's a lot of variability in our data, and that might be a less reliable factor to use if you're, say, looking at this in a scientific paper. Let's take a look at our equation for the standard deviation, which is sigma. We have a sum here, and we're looking at the difference between each individual value. That's the xi for each of these. Our mu here is our mean term or our average. We square this, and then we'll want to divide that by n, which is the population size, or in our case, it's the number of data points that we've got. Now that we have x minus mu, we'll need to square that term, and we'll put that just in the next column over. Here's our formula for that. The caret in most computer software means raised to the power of. So this is S2, our mu term, or x minus mu term, raised to the second power. Now we'll deal with this sum term in column U. We're using the same sum formula that we used to calculate the mean. Then we've got that right there. We'll just need a single number for this. It's not a sum for every single value. Now we'll divide by n. That's our number of data points. This will give us the equation within the square root symbol here that's termed variance. Variance is another measure of the spread of our data along with the standard deviation. Standard deviation, the sigma here, is the one you'll most commonly see though. The final thing we need to do is deal with this square root term. In Excel, it's the function called sqrt. We take the square root of our variance, which is this whole inside section of this formula. And we can see we end up with a standard deviation of about 0.1 hertz. That seems to be in line with our data set here, where the average variability would be within about 1/10 of a hertz or so. So it's always good when you come up with those final values to do a sanity check. Go back, look at your frequency data to see if it seems to fall in line with what you've calculated. Now that we have all the data we need, let's try to visualize this. Right now, we're looking at just lists of numbers. It's hard to know exactly what's going on with our frequency. So we'll create a chart called a histogram that allows us to better understand the distribution of these hopping frequencies and how far spread apart they are. To make a histogram, we'll want to go to the Insert menu up top, and our histograms are this box here. It looks like a bar chart. We'll just be using the basic histogram. Because we were good and labeled all of our titles up top here, it's pulled all of those in to our data sets. So make sure that all of these are properly titled and you understand what each of those is. Now we can go through and delete all the data sets that we're not looking for. We're not looking for peaks, we're not looking for the period, the total, the data points. We're only looking for frequency here. Now we can start to see what some of this data looks like. But because we only have two values, these two bars here, it doesn't give us much information. So what we'll want to do is right-click just anywhere on these numbers. Select the Format Axis option. That brings up a Format Axis menu on the right-hand side. Under the third icon, we'll want to change our bin settings. It automatically decided to use 2 bins here, but that's not enough to really understand what's going on with our data. It just divides it into a low frequency and a high frequency bin. I'll change that to 10 for my data set, but your data sets will vary a little bit. You might have to play around with the number of bins that works for your set. With more bins, we start to see a better distribution of the data. I have a lot of blank space here because I had a fairly small data set to work with. I only had 13 points. But you see, I did cluster around the center of this time, but I also did have a fairly large cluster on the higher frequency and then a little bit on the lower frequency. With more bins, we start to see a better distribution of the data. I have a lot of blank space here because I had a fairly small data set to work with. I only had 13 points. But you see, I did cluster around the center of this time, but I also did have a fairly large cluster on the higher frequency and then a little bit on the lower frequency. Remember that you'll be repeating these equations in order to estimate the mean and standard deviation rather than determining the calculated mean and standard deviation. If you don't remember what the difference is, you can refer back to this video. It's linked in Module 2, Instruction 2, under Intro to Mean and Standard Deviation. Your primary difference is that our calculated population, the one that we used before, is just n, the number of items that you have in the list. When we estimate it, we subtract 1 from that.